Hey guys, welcome to another geometry class. We are going to do 11.3 areas of circles and sectors. So the first thing we're going to do is find the area of a circle, and then we're going to find the area of sectors of a circle. So we've talked a little bit about circles already. Where we've done circumference, which is pi times diameter. So that's the equation we want to use there. Regardless of whether you're given radius or diameter for a circle, we want to use pi times diameter for circumference. When we're doing area, however, we're going to look at the radius and we're going to do pi times radius square. Make sure when you're putting this in your calculator that you're using the pi button. So for pi, we want to use the pi button on your calculator. And that just goes out more places and gives you a better answer for that. Okay, we have an example there for using the area of a circle. We have, if any of you play golf, I personally don't, but I have an idea of what a golf course looks like. And it looks like we're on a putting green here. And from the side view, it looks like an oval, but actually it is a circle. Okay, oh, bad circle. Let's back that up. We'll see if we can get a nice circle here. And it's got a diameter of 20 feet here because it's going all the way across. So 20 feet. Looks like I made my circle off just a little bit there. Get a little bit bigger. Okay, so there's our diameter and it's 20 feet. And we want to find the area. So area is pi is equal to pi times the radius squared. So obviously we need the radius. If the diameter is 20 feet, then the radius is going to be half of that length because the radius only goes from the center to the edge. So that's 10 feet. And we'll just plug it into our formula. So we've got pi times the radius, which is 10 feet squared. Well, I know that 10 feet squared is 100. So we've got 100 pi feet. But if I say the area of the putting green is 100 pi feet, it probably doesn't mean a whole lot to you. So we want to get an approximation of that. I'm going to take 100 times pi. I'm going to hit the pi button on my calculator. And I get, in this case, it does say to round to the nearest foot. So I'm going to get about 314 feet squared. It's a little bit more than that, but it's a good approximation. And then area, because we took feet and squared it, feet times feet is feet squared. In the next problem, we are given the area of a circle and we want to find the diameter. So again, we would like to insert some kind of circle here. You can draw yours in, but I'm going to put a circle and I want to just find the diameter. So let's put in a line here for the diameter. We will probably need to change that up. So there's our diameter. That's what we want, the length all the way across. The area is pi times the radius squared. So what we're going to solve for first is actually the radius, and then we're going to double that to find the diameter. We know that the area is 196 pi units, and we have pi times radius squared. I'm going to come back and divide by pi. And so that gives me that the radius squared is 196. And if I take the square root of both sides, I'm going to get the radius is 14. That's 14 yards. Now I didn't want the radius though, I wanted the diameter. So I actually need to double that and take it times 2 because diameter is radius, 2 times the radius. And so 2 times 14 would be 28 yards. So that is my diameter of my circle. Okay, what happens if we don't want the whole circle? We want just a portion of it, and that's the sector. That's the sector. For the area of a sector, we're starting with the area of the whole thing, which is pi r squared. But we only want a fraction of that. So we've got to figure out, well, how much of the whole circle do we want to look at? And this is where we look at that central angle that we talked about in the last unit, I believe. And so whatever that angle measure is, so the measure of the central angle, so the measure of the angle over, we know that there's 360 degrees in a whole thing. So that's what we're going to use. We're going to use the measure of that central angle over 360 and then times the area. And you can see that's what our equation is. Okay, but that's what we're going to use here too. So we have an example where we've got a pizza and it says a circular pizza has a diameter of 12 inches and is cut into 8 congruent slices. What's the area of one slice to the nearest hundredths? So we want just one slice. We'll just take this little guy right here, and that's going to be our shaded region. And here's what we know about the angle of this guy. That tells us how much of the circle we're going to use. Well, there are 360 degrees in the circle, and there are 8 slices. So I'm going to divide that by 8, which gives me 45 degrees. Okay, so 45 out of the 360 is how much the circle is, or how much the sector is. So 45 out of 360, and then we're going to take that times pi times diameter, which is the area. So I'll say area of circle. So I'm going to multiply pi. It tells me that the diameter is 12, so the radius has to be 6 inches. And so if I'm going to do radius squared, I'm going to take 6 inches squared. So let me write that back out here. What we did is we took the measure of the angle over 360 times pi times radius squared, which is the area of the whole circle. So that's how we came up with that equation above there. And then we're just going to put that right in our calculator. So in parentheses, if I were putting this in my calculator, I would want to put 45 over 360 in my calculator probably. 45 divided by 360 in parentheses. Then I'm going to say times pi and use my pi symbol. And then times 6 squared. And it says round to the nearest hundredth. I end up with about 14.14 inches squared. So I'm eating 14 square inches of pizza, which sounds pretty good right now, actually. All right, for our next one, we've got a different shaded region. And so it's not what's not shaded, it's what is shaded. So I've got to kind of create a little bit of a plan for this. We can do a couple of things. We can either find the area of the whole circle and subtract a little piece, but that seems like a lot of work. Or why don't we just find how many degrees are in the shaded section here? And so we know that there are 360 degrees in the whole thing, and if we subtract the 65, that's how much is in the shaded region. So 360 minus 65, I get 295 degrees. So that's the shaded sector. Now, when I want to go and find the area of that shaded sector, it is the measure of the angle over 360 times, so that's how much of the shaded region we have, times pi times radius squared. And then I'm just going to fill it in. So 295 is the measure of the shaded section out of the 360. So that's the fraction of the circle that we're using, times pi times our radius looks like is 11 inches squared. And then I'm going to put that in my calculator. So again, in parentheses, my fraction, I'm going to put 295 divided by 360 times pi times 11 squared. And again, we're going to go to the hundredths place. That's about 311.50 inches squared. So that's how much of the shaded region we have in that one. Okay, we have a short assignment over circles, and then on the next page. If you have any questions, please don't hesitate to message me, and I am happy to help you out. All right, have a great day.